Let me start recording, and as more people join, I'll just talk more. But let's first give Vicky a little bit of insight into your exam. So what I could pick up, and we are in communication with the lecturer. So she has basically we in a WhatsApp group together, some of the tutors with her. So basically on Monday Monday or Tuesday they'll send out um, some or not exam example, but what you need to know about the exam. It sounds very similar to what you did for that online assessment. Um, so it sounds very similar to something like that. That it will be on the MyUnisa platform, and that will be the way that you will answer your multiple choice exam paper. So, and that's why I think they're giving the things that you would have gotten with the paper, like formulas, like the binomial, the Poisson, the Z tables, the chi-square tables, all things like that will be basically given to you as well. So I would suggest when you get that you nearly, if you are able to let it print somewhere, or if you can print it, I think that would be the best, nearly to have it as next to you when you write the exam. The other thing is that, and again, dependent on what you have available, and what technology you have available. So it seems like the questions can be random, that we can't use the WhatsApp group kind of to get the answers. And it also seems like, as with your assignment that you did online, that you can't go back. And I think the reason for that is more that you can't communicate with somebody else to go back to a previous question, which I still don't like. As normally I would have wanted to page through the exam and see which ones are for me the easiest to do nearly, and then do the more difficult ones later. But that seems like how it's going to be. So the other thing that I would do is, and as we go through the next paper, so I think we need to go through a few questions still on this paper, and then the next paper we basically will start from question one. So there again, I think on your first few chapters, where it was where you need to decide between nominal and ordinal, and so there I would nearly have, because you have this opportunity now nearly to have, and in the olden days we called it a Cripps sheet, nearly, kind of, that you write for you, this is a nominal distribution and this is the example, so that you nearly have a page next to you, that it makes it just easier when you write the exam to nearly say, okay, this is what I'm looking for, this is the answer. So even if you, I think, like, I'm I think lucky where I'm sitting in a study where I've got boards next to me that I can put on stuff. So even if you have that available to you, and you can, even if it's just papers that you put up on a wall, where you can just get easy access to it, that you don't need to go through your book nearly to get some of the information. I think that would help as well. What we also discussed in one of the other subjects is nearly you can, even if you have that available to you and you have multiple devices nearly, that there's things that you can have on your cell phone. If you're doing it on a laptop or a computer, you have your exam running there, but you can have access to other things on one of your other devices if you are in that position to have it. So just a few tips and things to make it just easier for you. So even if you have somebody else's cell phone, that you nearly have 2 or 3 cell phones that you can use on that day to nearly navigate things, also to make it easier for you. But let's go into the last few questions of this paper, and then we'll start with the next paper. But please, I think we're not a lot of people in this session. So again, if you want to ask a question as we go along or want to raise something, please do. Really, it's not a big class of 70 or 80 that we need to manage. I think we currently only 12 guys in the session, so I think more people will join, but please feel free to ask questions as we go along. Okay. You guys can see my screen, hopefully. Yes.
Yes.
Yep.
And I quickly want to get to. Okay, so we were basically at question 21 last time, and I will put it into. Let's just see if I can make it a bit bigger as well, that you can just see it a bit clearer, so that I can write on it as well. So basically, and the things that I again would for you in the exam to look for is, so let's just read the question, and there's nothing in the question that nearly tells me what I need to do. So a popular weekly magazine asserts that fewer than 40%. Okay, so that's the first thing that we pick up. Fewer than 40% of households in South Africa have changed their lifestyles because of escalating gas prices. A recent survey of 100 households found that 67 households have made lifestyle changes due to escalating gas prices. And then they ask which one of the following statements is incorrect. Okay, so they don't tell you here it is proportions, but because we're working with so many households out of the 100, we are working with proportion. So you will also see that they don't give you a standard deviation, they don't give you a mean or anything. So the only thing that we can work with is proportion. And then basically that is your, and let's call it, I don't know what to call that, so let's call that pi. It nearly looks like a pi sign. So the 40% will be the pi, and then the 67 over 100 will be your p. Okay, so let's look at the first option. They ask, tell us the null hypothesis is pi equal to 0.4, and the alternative is fewer than 40%. So that is correct. So that is automatically correct. Then the next one, Statistic you need to work out. So I will normally leave that one let's quickly, I just want to see if there's, sorry, there's somebody that I need to give access to. I hope he is in the room. Ruan, did you get access? Oh, sorry, Mark, did you get access? Are you in the
Yes, I have.
session?
Thank you.
Okay,
Thank you very
cool.
much.
Okay. So if I look at basically, I need to work out the test statistic. So I'm like, ugh, do I need to do that now? Do I first look at the other options, and maybe one of the other options can be the one that is incorrect, but I rather look for that before I start working out a large sum. So let's look at the critical value of alpha equal to 10% is 1.28. So that we can get from the table. And if we look at the table, we would need to say, okay, and that is maybe a question to you guys. Which table will you use? As we spoke last week, nearly, would you use the Z or would you use the T? And you can nearly give me a response. We're still a small group. So what would you have used in the exam?
The Z table.
Okay, awesome. Okay, so Z table. And then the Z table, what we basically would do to find that value is if we go, and this is now, so I actually need to open the Z. So let's quickly see if I just not have it on here. So let me quickly, I'm going to get it so that we can just, that I can just show you how to look for it, because I think that is also important. So let me just go and find my document with all the tables in, because I think that is okay. So let's quickly share and okay, cool. So I think you guys can see the PDF that I'm just running through with with speed to get to the tables. I'm hopefully not past it already. Okay, cool. Okay, so we need to look for, they tell us it is 10%. So they tell us that portion is 10%. So we know the rest of the portion is 90. So we need to look for value here that is 90. So 0.90. And what we see then is that between these numbers nearly, there is 0.89, so it's nearly 0.9, 0.8997. So this is, if you round it off, you will get 0.9. And then if you look at the number, it is Z that is 1.8 or 1.28. So that is how we look for that value as well. They tell us it's a 10% alpha. So if we say 1 minus 10%, we get the 0.9. And then basically we need to go and look for that 0.9. And that 0.9 basically, it lies in between those two numbers, but it lies closer to this one, and that's why we pick the 1.28. Okay, so that would then mean that if you look at the options, I just need to share the so that would mean that the critical value when alpha is 10% is 1.28, and that is also correct. Okay, then the p-value equals to 0.0009. Unfortunately, to get that, we need to work out that one. And then the last one, the conclusion, the null hypothesis is not rejected. Okay, so I want to show you what I would normally, how I would draw that. So even before we work out the other two. Okay, so we've got the value here of 1.28. So if your test statistic is smaller than 1.28, we're gonna accept the null hypothesis. If it is bigger than 1.28, we're going to reject it. Okay. So even if you look at these two values, even if we haven't calculated it, it seems like your t-stat is lying to this side, which tells me that I am going to reject the null hypothesis. So, and then this one where they say I do not reject is the incorrect one. Okay, so that is even before I work out the t-stat, but we can also work out the t-stat. So I actually want us to do that in any case, so that you can just see what we would have done there. So to work out the t-stat, we still use the Z formula, as it was identified that we look at the Z table. See, this will also now, I think, Rian, you mentioned on the chat this afternoon. So this will be one of the formulas that you will get. So it is, again, one of those things that if you can get it beforehand, you can print it, then you can actually write on that as well to say, this is the formula for something specific, instead of where normally you would have just gotten the formula page in the exam. Now you can actually make notes next to all the formulas that they give you as well. So I think that is also nearly a positive for this exam, is you can actually make some notes beforehand as well. Sorry, I just needed to take a sip of coffee. So let's just go quickly on. So we know the P was 0.6. We know the pi was 0.4. So that will be above the line. Below the line is the 0.4.
It's 0.67.
0.7, sorry, thank you. Because I was now thinking that is just odd that when I say 1 minus 0.4, I get the same. So thank you, it is 0.67. Did I at least, yes, okay. 0.67. Then below the line, it is the 0.4, and then if you say 1 minus 0.4, it gives me 0.6, and I divide it by the 100, the n, and remember that whole thing needs to be square root. So that will give me something like 0.27 divided by 0.049, and that would have given me 5.51. So I would have gotten that number. And then if you even look at the Z table, there isn't even a 5. I think it stops at 3 or 3.5 or something like that. So then we know the p-value is very small. So it is nearly 0. So that means that those two would have been correct in any case. Okay, but this is how you would have worked out the Z, and then you would look for that Z value on the Z table to work out the p-value, but you won't see it there. So then we know the p-value is really small, so it is nearly 0. So that is why 2 and 4 is also correct. So the incorrect one was the number 5. Okay, so this is, and I think this is nearly how you would probably get it in the exam as well, because it tests nearly everything. So it tests that you know what the hypothesis, how you structure that. It tests that you can work out the t statistic. It tests that you know how to get to a critical value. Then it, in conjunction with the t-test, it basically allows you to look for the p-value, and then it nearly tests you what your conclusion will be if you reject or accept the null hypothesis. And they don't need to always say the null hypothesis. They can look at the alternative hypothesis as well, just dependent on what they want to ask. Okay, questions on question 21.
Yes, I do have a question. I was
Yes.
calculating it and I'm getting 5.501.
5.50.
No, I'm getting I'm getting 5.511.
Okay, see, so that is close enough.
Yeah, rounded off. Yeah, yeah,
Yeah,
it's fine.
so and I think when also in the exam, see now where I rounded off there and I worked with a rounded off number. In the exam, try to work, if you calculate that, try to work with that whole number that you have calculated there and not work with a rounded off number. And that will just have a few impact on a few of the decimal numbers. Hopefully this time around they don't play around with some of the decimals. Like I made a mistake last week where they swapped two things around, so they won't in a question like this 5.5101 and 5.5103 or something like that, but they could have had 5.51 and 5.15 nearly, but they won't play around with 2, 3, or 4 decimals, kind of rounding off. So you don't need to worry about that. But I think it is important that you try to work with as most of the decimals as possible. Okay, another question on number 21. Okay, let's move on to the next one, which I think is also the one that I think it's an important one, the p-value and one-tail, two-tail kind of test. Just everybody just switch off mic that I don't get the background noise. So okay, cool. Let's go on with question 22. This is also recorded, so for the guys that are joining a bit late as well, it is recorded, and somebody will try to make it smaller again and put on YouTube. Okay. Question 22. Suppose the p-value is a one-tailed test is 0.0092. Based on the sample population, or based on the same population sample and null hypothesis, the p-value for a corresponding two-tailed test is what? And I think this is nearly one of those, it doesn't matter which way you go, there is probably an answer for you. So how I looked at it is, so they tell us the p-value for one tail is 0.0092. Okay, so if it was based on the same population sample and null hypothesis, what would it be for a two-tail? So what will that p-value be there? So remember, two-tail, it's now sitting at both sides. I nearly want your input first. What would you have done in this situation?
Then I would multiply that 0.0092 by 2 because it's two-tailed.
Okay, anybody else? What would you have done?
Yeah, I would have done the same, I think.
Okay, so perfect. That is what you do. So you basically multiply it by 2. And then I think if you multiply it by 2, there is your answer. Now, I think what is important, and that's nearly to the previous question of the 5.5102, look at, again, it's how they just swapped it around. So obviously number 2 is wrong, but now they swap the numbers around. So that is what they nearly like to do, because again, you in the exam, you multiply it by 2, you quickly look and you're like, oh yes, there was the numbers 1, 4, and 8 was in it. You pick option 2, but it is actually option 3. And luckily, what they normally would have given you as well is the option if you divided it by 2. So luckily for this instance, there wasn't that option, because that can also create confusion. But if I give you the one tail, you divide or you multiply by 2 to get to the two tail. If I give you two tail, you divide by 2 to get to the one tail. And I think that is the important thing. So to move from one tail to two tail, you multiply. But if you have gotten the number 0.0092 as a two tail, to get back to the one tail, you would have divided by 2. And I think that's the important thing to remember and that now looks like a smiley face. But that is the important thing to remember, that if you move from one tail to two tail, you multiply by 2. If you move from two tail to one tail, you divide by 2. I think that's just the important thing, that when it doesn't matter what they ask you in the exam, you nearly know the order of doing it. Okay. So let's move on to the next one. I think this is where some of the, I don't want to say difficulty, but there's some of these options that takes a lot of work. So what I normally again look for is to say, okay, let's see if I, and nearly let me, if I look at that, and we've seen in the assignment as well, to calculate the test statistic for the chi-square is a lot of work. It is not a simple just subtract two numbers, divide by a number with a square root. It is really a lot of work because you first now need to use your observed, you need to work out the expected value, you need to start subtracting, you need to add nearly all of them. I think the formula is somewhere as well. So it is really a lot of work, and the chances that they would ask you something like that is very slim. But let me rather how I would have answered it again. So looking for the incorrect one. So when we look at chi-square, we know that that the null hypothesis is always independent. So that again is something that you can write down on a paper. It is always like that. So if it's not in the answer like that, it is incorrect. So null hypothesis, always independent. Alternative hypothesis, always dependent. So those two are correct. So if it was in the exam and it was then swapped around, then both of them are actually incorrect. So null hypothesis for chi-square always independent, alternative always dependent. Okay, then I also always like to work out the degrees of freedom, because that is the easiest sum to do. So for chi-square, the degrees of freedom is nearly worked out with a formula like r minus 1 and c minus 1. So you multiply the two. And what all that is looking at is how many variables are in the rows. So there's 1, there's 2, so it will be 2 minus 1. How many variables are in the columns? There's 1, 2, 3, 4. So it will be 4 minus 1. So we will have 2 minus 1 is 1, 4 minus 1 is 3. So if we multiply the two, the answer is 3. The one thing that you must be aware of here is total is not part of the variables. So sometimes they give you the total that you have it as is, but you must not take it as one of the variables. Sometimes they don't give you the total and you need to work it out on yourself as well. So it just depends on how they ask it. But when we work out degrees of freedom, total is not one of your variables. So the degrees of freedom is free, so that is also correct. So then again, I would first try to look at the table for my critical value before I go to work out what the t-stat is for chi-square. So then again, if we look at your chi-square table, and I will quickly show that to you as well. I'm just going through the PDF that we just show how to read that as well. Let me see on which page that is. Okay, on page 200 of your study guide. So let me just share that again. Okay, so on page 200 of your study guide is the chi-square table. So how we look at this, so we've worked out the degrees of freedom is free. They tell us, and let me just quickly see, so they tell us that we need to use the 5% level of significance. So if we use the 5% level, it is the 0.05. So we would go down to where it crosses the degrees of freedom of free. So we sit there with the 7.815. Okay, and then if you look at your options, so let's just share. And again, so if we look at our options, it is 7.815. So we know that then this one is also correct. So the wrong one is number 5, which is the incorrect one. And it, as you would have seen in the assignments, to work out that is, it will nearly take you 15 to 20 minutes in the exam. So that's why they nearly also won't expect you to work it out. They would rather give you the other options. So it doesn't mean that will also be the wrong option every time. It could have been that the degrees of freedom was also wrong, or one of the others are also wrong. But I would nearly go through all the other options and then only will look at the last option where you need to look at the t-stat for the chi-square. Okay, so because if you need to work that out, it will take you probably 10 to 15 minutes in this example of question 23. Okay, questions on chi-square. I think the next one is also chi-square. So let's look at that as well. So interesting here. So they ask you to work out the critical value at 1%. But that is all that they give you with a table. So you now need to work out the degrees of freedom first. So we know there's 2 rows. So 2 minus 1 will give you 1. And we know there is 2 columns. So 2 minus 1 is 1. So your degrees of freedom is 1. So with degrees of freedom 1 and 1%, we now need to go again to the chi-square table and see what the value is. So I want to share it again, because then it's nearly good practice that we are doing this and getting it right. Okay, so we said that we are looking at degrees of freedom of 1. we said that we are looking at a value of 1%. So remember, 1% is not 0.1, but it is 0.01. So our value would be 6.635. And just for interest's sake, remember what the 0.1 value, it is 2.706. So when we then go back to our questions, the value that we're looking for is 6.635, and it is sitting there. And now look at, yes, there's a 6.365, so very easy to make that mistake, very easy to make. It is very difficult. Okay, so let's quickly see if somebody wants to come in. Okay, I will just watch if somebody else still wants to. Okay, are you guys still hearing me?
Yes,
You
Jim.
did.
Or you can come first, then I'll come later. Hi, Jim.
I was just gonna say I didn't hear any of that. You disappeared for like 30 seconds.
Okay, so yeah, I think there was now, I saw on my network as well, I had a bit of a network issue. So let me rephrase this again. So could you guys see when I looked at the chi-square table?
Yeah.
Okay. So basically out of a chi-square table, the answer that we got for the 0.01 with the degrees of freedom of 1 was 6.635. But as in some of the previous questions, again, if you quickly look at it, there was two others that are very similar, that one can make the mistake. And even if you were at the 10%, there was the answer for you as well. So that was just for me to say, it looks very simple, but there is a few tricks in here that nearly can catch you out, especially in the exam when you are rushing and you want to get through things. So option 4 is the correct option. Okay.
Jim?
Yes, ask please.
Yes. On the second option, can you please just repeat?
Okay. So, and I'm going to share the PDF again of a table. So let's just share that again. So they tell us that we are working with is a 1%. So remember, 1% is 0.01.
Yes.
Okay, but if you quickly in the exam go through it, sometimes you can make the mistake to say, oh, 1, it could have been, oh, I'm seeing the 1 there. You could easily make the mistake to use that one.
Or to use the 10%.
And then if you make the mistake to use that one, there is actually an answer for you. And that for me is the scary thing. So the other option that you would also see is the 9.21 was when you worked out the degrees of freedom wrong. So then that was another option. Okay, so let me go back to sharing. So if your degrees of freedom you worked out as 2, you would have had to answer as well. And that for me is nearly the scary thing, that there's nearly, for the option of working with 10% instead of 1%, there is an option for you to have picked for degrees of freedom working with 2 instead of 1, there's an option to pick. So again, it seems very simple, but there is a few catches in this one.
Hi, Jim.
Yes.
Yeah, sorry for taking so long.
No, don't worry. Another question?
And then on the same 1%. Jim?
Yes, quickly repeat that. I couldn't hear.
Okay. I was saying the question paper that I'm having, it says a 10% level of significance, but the one that we have projected, it says 1%.
Hi, Gene.
Yes.
He's sitting with the 2019 paper, because that question of the 10% is in the 2019 paper, and you are busy with the 2018 paper.
Okay,
Oh,
thank
so
you.
my apology for that.
No, don't worry. So, and again, it shows that a lot of the papers are being recycled, and they just change some of the numbers. Okay, so yeah, this is a 2018 paper that we are looking at.
Oh, thanks for the clarity. Thanks.
Okay, cool. Thanks for highlighting that as well. Okay, so that is where the difference is, and that's why I nearly want us to work through a few papers, because you will see a lot of the papers are recycled into just using the same principle. Yeah, so even some of your assignment questions, even if for practice, if you have time, which I know is a bit of a problem, but even if you look at next semester's assignments nearly, if you have time, then you can also ask me to look at some of them for you, or we can on the WhatsApp again discuss and things like that as well, because a lot of the questions is just recycled in some or other way. Okay, let's get to the last one, and then we can go to the next paper. Okay, so question 25, and here again, I've seen in the online assessments that there's things that in your study unit under regression, suddenly there was questions in the online assessment where you needed to use formulas of B0 and things like that. So I think it's important that there's a few things that they can ask. And yes, I got the online assessment PDFs in the week, so I will forward that to everybody, that you guys have that as well. But I think it is important nearly if they give you the X and Y value, then I would normally use my calculator to work out the B0 and the slope and the things like that. But I was surprised that in the online assessment, they actually gave you a lot of information that you needed to use one or two of the formulas. So, and I think somebody asked me about the formulas, and I took a picture out of one of the exam papers because I also couldn't find it in the study guide. It was probably again in the textbook. So again, in this exam, there was only one question on study unit 11. I think when we look at some of the other papers, also one or two. So it is not a lot, but it also can be that there's an easy way to get marks in this one or not. So let's look at question 25. So they ask us for the correct statement. So let's look at dependent, independent values. So first of all, the first one, the X is actually the independent one, but also how we can look at this one is if that was right, if it was dependent, then the Y is also right because then the Y needs to be independent. And because we're looking for the correct one, both of them can't be correct. So if you even haven't remembered what it should be the answer, nearly if you look at those two, you can say, but it can't be both right. Otherwise, they made a mistake in the exam and then the question will in any case be thrown out. So it could not be. So both of them are incorrect. And that is just another thing for you guys. So if they make a mistake, like in some of the assignments where there was a mistake with a question, that question is not marked. So it is then that question is dropped and your paper will be out of 24 questions or something like that. So when they pick up that they made a mistake, it's not that you will get 0. So it's all that you get, everybody gets the mark, or they drop it out of the question, just to set you at ease if there is problems like that. Also, just on that point, so if you feel that they've made a mistake somewhere, and it is online, and you want to take a pic for later on to share with me, share directly with me and not to the whole group, and I will take that up with the lecturer as well, that they can look at it. Okay, so then let's look at the third option. So we're looking at the slope. The slope is always linked to the x. So there should have been the x. It was just terrible how I scanned this in. So we know that is the slope. Okay, so at least that one is correct. So in the exam, number 3 is correct. I wouldn't even have gone on to the next question. But let's look at the next two questions. So there is no relationship between x and y. Yeah, they in the same formula, so there needs to be a relationship between the two. It doesn't here say it's a good relationship or positive or negative, or strong or bad relationship. Here they say no. And if it is in the same formula, there is a relationship. So that one is also incorrect. And then the next one is, so the estimated value of y, and that again should be where x is 0, is 0 0.375. So if we put 0 in there, that will basically equal to 0, because you would say 0 times 3.75 is 0. So your estimated value for y is actually 1.125 and not 0.375. So that one is also incorrect. So the correct one was option 3. The slope is equal to 3.75. Okay. So are you guys happy with this? I think again, with the regression, unfortunately, there is a few ways that they can ask it. So this is one of the ways. The other way is to give you the data and have the same kind of questions that they ask around the data. Or the worst case was like in one of the online assessments where they gave you the sum of X was, the sum of Y was, the sum of X and Y was something, and you needed to work out some of the calculations. That for me is worst case. And again, I don't think they would go that route just because it takes so long. Again, you don't have lots of time. I think in the exam, yeah, you're getting 25 questions. If I'm correct, it is, what is it, 2 hours that you get for it? Yeah, so 2 hours for 25 questions. So you have 4 minutes. Wait, no, it's less. What is 120 divided by 25? So that is what you have. So you have 4.5 minutes or something like that per question. So they will not ask you to work out in detail like they did in some of the assignments and in some of the for online assessments. Okay. So happy with basically paper 2018. I think we've done from the probability. If we have time, we can go back to the first few questions of this paper later on, but I think we can nearly start. We still have a half hour to go, and we can actually go into the next paper if you guys are happy with that. And then we start nearly from the beginning.
Would you mind if we have like a 4-minute break?
Yeah, let's do that. A coffee break. If anybody still has smokes, a smoke break. Yes, let's start in 2 or 3 minutes again.
John, I'm struggling to hear you.
Good on this side. Are you good? Hi. Okay, is everybody back? Let's see.
Yep.
Okay, let's start again. Yeah, and let's start nearly from the beginning. This the October November 2018 paper, and this is nearly where.
John, can I please ask a question before we
Yes, please.
continue?
Yes,
The
go.
paper we just did now, question 21. How do we get the p-value? I struggle with it.
At question 22. So the one that I have now on screen. Okay, so if I heard you right, you were saying how did we get to the p-value of question 22? So the p-value of question 22, they give us a one tail, and they say to us the p-value for the one tail is 0.0092. So to get that to a two-tail, or what the corresponding p-value for a two-tail will be, is we will multiply it by 2. And if we multiply the 0.0092 by 2, we will get the 0.0184. And I think the important thing here is also, if they've given us the two-tail, then to move back to the one-tail, we need to divide by 2. And I think that is the important thing, and it will be interesting to see in other papers how they ask it. But if I give you the one-tail p-value, the easiest thing for you to do is to get to the two-tail is you multiply by 2. It is as straightforward as that. You don't need to go to tables. You don't need to work out a different way. You just multiply by 2. Okay, happy with that? Okay, so let's, if you can ask another question if there is, otherwise we can go on. The line is, for some of you guys, the line is also not too good. So Rian, did you do the recording to YouTube last time?
Yeah, I did.
If it's fine on my side, then the recording is also fine, I assume.
What do you mean fine on your side?
If there's no issues of connectivity on my side and I don't break up, then the recording is normally also good.
Yeah, I think so. I think it records from your mic directly.
Yeah, so hopefully the guys that have some connectivity issues and the line drops and things like that, the recording at least, you will be able to see the full thing unless my line drops, basically. Okay, so let's go to October, November 2018. And again, this is the same process. So we'll nearly work out a few of these papers until you write exam. So for me, when I look at this, what is important, and then nearly why I want to say have your crypt notes or something next to you, because that you can in the exam. So they say qualitative. Okay, so what is qualitative? Nearly write a definition for you, and then it's nearly easy to say, okay, what is qualitative and what is not. So for me, and Neely, I want to get your guys' input here as well. So is human blood types qualitative, yes or no? So what would you say? Qualitative, human blood types, yes or no?
Yes.
Yes.
Okay, so yes. So then, before we go to B, I would look at this and say, okay, there's a A, there's a A, there's not a A. Okay, so we already eliminate option 3. Okay, so then household size collected by Census Bureau, qualitative, yes or no?
No.
Okay.
No.
Does everybody agree? So no. Okay, so oops, not that one. Any place else? B? No. Okay, so soccer player height. Qualitative, yes or no?
No.
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 Okay, awesome. Okay, so eliminate that one. So we're sitting with 2. So we already know that one is not an option even. Ethnicity. Qualitative, yes or no?
Yes.
Yes.
Yes. Okay. Option A and D. Okay, so it is when your answer is option 4. So that nearly is for me how I would. Yes, we are now taking a bit of more time in this, but that is how I would nearly go for it. Is start at the top. Then eliminate some of our options already. So there's in one of the groups that we always make a joke. If you at least then you guess between 2 or 3 options and not all 5 numbers or all 5 options. So I think that is just again in the exam to make it easier for yourself. Okay, so but again, with your time that you have in the exam, nearly and I'll see how I can help you with that as well. But nearly prepare yourself with the time allocated and the information that you can keep at hand to make it easier for you. Okay, so question 1 was in a sense easy because you could go and nearly look at qualitative and reason out which one is qualitative or not. When we get to these ones that in each one they nearly ask you a different option, it's not difficult, but you need to keep your head and nearly keep to because they do throw in different variables together, and it's not just as easy to say no, this is right, this is wrong. So, and you need to nearly read all of them. And the other one that is also they mostly ask you to look for the incorrect one. So this is nearly type of definition question, but it is then not straightforward as some of the other definitions. So let's look at the options, and again, I think let's work through it together, and I'll nearly post you the question. 4 different beverages, soft drinks, tea, coffee, and bottled water are sold at a fast food restaurant, and they say, is it a nominal variable? So what would you guys say? Nominal, yes or no?
Nominal.
Yes.
Okay, nominal. Does everybody agree?
Yeah.
Okay, so easy one, first one, well, not easy, but it is correct. So unfortunately, we need to go on. Next one, South Africa businesses are listed by small, by size. Okay, so that already tells me something. And they tell me small, medium, large, and they tell me it is ordinal. Correct or not?
Correct.
Correct.
Okay, correct.
Yes.
So they told me it is size, and then they tell me the size is small, medium, and large. So it is in a order, so it is ordinal. The time it takes to download a video from the internet is a discrete variable.
It's very tricky. Yeah.
See,
Incorrect.
and now that is the tricky one. So what is a discrete variable? And I think that is, if you now need to remember from some of the things we did, or you did way back at the beginning of this semester, chapter 1 or 2, the
Yes.
definition of the discrete. So it is a variable that is like a 1 or 2 or 1 point, I think maybe there's a 1.1 as well, or 1.2, but it is, you can actually name the number nearly. So I'm not 100% sure that the time it takes me to download and the times it takes somebody else to download is nearly the same number, and I can say it is 1 second or 2 seconds or 3 seconds. So I am not 100% sure if this one is correct, so I rather first mark it with a question mark to say I'm not sure. If they told me it takes a certain number of minutes to download, then I would have said automatically, yes, it is a discrete. And that's why a few of you said this is a tricky one, because it is tricky. So I'm not 100% sure yet. So let's go to the other two options. Whether the cell phone owned in the household is a smartphone represents a qualitative variable, yes or no?
That's
Yes.
correct.
Yes.
Okay, awesome, correct. And then the distance in kilometers from a person's house to the nearest store is a quantitative variable.
Yeah,
Yes
that's right.
Yes.
So right.
Cool. Okay, so if I said the
Correct.
time in seconds to download a video, then it was a discrete. But because we just say the time it takes, you can't pinpoint the time, so that's why it's not a discrete variable. Okay. So that, again, so that is the trick in this one. And that's why if they said to us distance, somebody travels again, you would start asking, it will still be a quantitative variable, but if they don't tell us a certain kilometer, because this can also be a discrete one. So it depends on nearly the phrasing of that question. So the wrong one was option 2, option 3. Okay, let's move to the next one, and here we're talking about frequency distributions. So at least I think we can still work out one or two. So for this year, so which year that was, 2018, a random sample of 500 incoming college freshmen yielded the following frequency distribution for political views. Okay, so they said there was 160 over 500 that voted or had a political view ANC, 246 that had the value of TA, and 94 EFF. So the relative frequency of ANC is. Okay, so what can you remember? What is relative frequency? And I think that is nearly, is it a number or is it a percentage?
Your answer, I think, will end up in a percentage. So you take your variable for the ANC, which is 160, divide by the, you take the random sample divided by the 500. So it's 160 divided by 500 is 0.32.
Okay. Does everybody agree with that?
Yes, I agree.
Yes.
Yes.
Okay. And also very interesting. So they do give you the 160 just to throw you off, and I think that 160 is it's not relative frequency. I think that is just called the frequency, if I am correct. I will go back to my notes again. So again, look at what they ask. So if I ask what is the frequency of ANC, it would have been 160. But they ask what is the relative frequency, then it is 160 divided by the 500. Okay, so perfect. Let's just take that out. So another one that you will get in the exam is a stem and leaf. And it just depends on how many of the stem and leaf I want to ask, but it is something that you will get. So again, how I would look at it is you will get 2 questions on nominal variables and qualitative variables and things like that. On distribution functions or the graphical distribution, again, you will get 2 or 3 of them. Then on the averages and things like that, again, 2 or 3 questions on that. So let's quickly look at the stem and leaf. And how I normally look at it is, so by first, it's important to read what they tell us. So a stem and leaf diagram for the days to maturity data is shown. So we know that is 36 days. So the minimum is 36 days and the maximum is 86. So to get to, now they ask incorrect one. So to get to the range, it is normally easy. It's the maximum minus the minimum. So it would have been the 86 minus the 36, which would have given you the 50. So that is correct. Then the 5th largest number. And I think that is, so you now need to, again, sometimes one will make the mistake to say, go 1, 2, 3, 4, 5. Got it, 50. But that's not the largest number. So the largest number is coming from this side. So it's 1, 2, 3, 4, 5. So the largest number is actually 80. So that is the incorrect one. Okay, so again, very easy to make a mistake because you nearly want to, the brain nearly wants to tell you to work from a top down, and then 50 would have been your chosen answer, but that is the wrong one. So the 5th largest number is not 50, it is 80. But let's look at how to get to the other ones as well. So sample size is just how many members. So if we count all of those, it will add up to the 33. So we can just quickly do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it adds up to a 33. So basically that is your sample. Mode, what is the mode again? Is the number that appears the most.
Correct.
Cool. So I'm looking at these 2 5s there.
70.
Awesome. And there's 370s, so the mode is correct. Median, and sorry for the dog in the background. If you can hear him, he is hungry and it's not feeding time yet. So the median is 64. What is the median again? It's
The middle
your
number.
awesome. So we know we're working with 33. So half of that is 16. So between 16 and 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Between 16 and 17. So between 64 and 64. So it can only be 64. So the median is 64. So the wrong one was the second one, and it was an easy one in the exam to, if that is in the exam, you stop there. You don't even test the other options. You know that one was the wrong one, and you go to the next question. But you will get the stem and leaf in the exam. Okay, so let's round off with the last question. Question 5 for tonight. Consider the data set 1, 2, 3, 4, 5, 6, 7, 8, and 99. Which measure of central tendency is not affected by the outlier? So the first thing, if we look at that, what is the measures that is sitting under that?
The mean, median, and the mode.
Awesome. So mean, median, and the mode. So they ask, so which one is not affected by the outlier? So we only have to choose between those two because it's not the range, it's not standard deviation, and it's not sample variance. So if in the exam, if you needed to guess, there's 2 options and not 5 options. But which one is not affected?
Which one is affected? That's the question.
Is not.
Oh, is not.
See, and again,
yeah.
that
Correct.
is, so again, it is very important in the exam, because ones quickly want to also think, I know which one is affected, but which one is not affected by the outlier.
Yeah.
The median.
The median.
Awesome. Okay, so the median is not affected because the median is the middle number, so it doesn't matter what the outliers is, you will still get to a middle number that is, I think it was 5. 1, 2, 3, 4, yeah. Where obviously the 99 will have a huge impact on your mean. So it will skew your data where it doesn't have any impact on your median because that should have been 9 and was probably a typing error. So it has an impact on your mean, but not on your median. The reason why they didn't include mode here is because there is not a mode because every number is just appearing once. But it is also not supposed to have an impact on your mode unless there's 2 outliers of 99. So that would have been, but the reason why they haven't included the option of mode is because there isn't a mode because there's just one number of each. Okay. Okay, so I think let's do this one still, and then we can stop. Okay, because yeah, this one I want to quickly see if there's an easy way of showing this to you. So distribution of the following data. So then they give us options. So I would rewrite this, and I would rewrite it in a small diagram. So I would say, I would write it as, there's my 0, there's my 2, but I would write it with 2's on top. So I would nearly write it as a stem and leaf, but just a bit different. So upside down stem and leaf, and then the last number is 4. Okay, so, and then you can nearly draw a diagram on it to say, okay, how does my data look? Because that is what they are asking. So they say, is this data symmetric because the mean, median, and mode have the same value? So if we look at that, definitely the mode is 2, the median will also be 2, and actually your mean is also 2. So that one is true.
Correct.
Was that the whole question? So the distribution of the following data, so that is your right answer. Okay, that's actually awesome that you don't need to, but let's just look at the other options. So option 2, positively skewed because the value of a mean is greater than the value of the median and the value of a mode. So that, something like that would look, so if there was more values of a 4, then it will probably be skewed. The same if it is negatively skewed, then it looks something like that. So positive skew is that, negative skew is the other way. So we saw that it's nearly a normal distribution. So it's definitely not positively skewed or negatively skewed. Uniform is when the diagram would have looked like that. So if there was 3 zeros, 3 twos, 3 fours, then that is a uniform distribution. So when it nearly makes a block, then we know it is a uniform distribution. So it is definitely not that. And a scatter plot, for a scatter plot, we need a X and a Y. So we need basically like a time series data, or like in study unit 11 nearly, when you look at regression, we need to have more than just one data point. So at the moment we only have one data point, so we can't use a scatter plot to show it. We need an X and a Y to do a scatter. So it's not option 5. So for question 6, there was just one answer, and that is option 1. Okay, I think we'll stop there for tonight. It was a long session, but I think we did a lot in this time, and we'll just continue. So I was before we leave, you guys are writing the 9th, which I saw it's a Tuesday, so we can nearly, I was thinking of, and you guys must, I'll do a bit on the chat as well to see how we can squeeze in another 3 or 4 sessions like this, and probably an hour to an hour and a half session that we work through another few exam papers and just continue on this basis. But I'll chat to you guys on WhatsApp to see which times will suit you, and if we need to make it a bit earlier, or if this for me is a good time, the 4 to 5:50 slot nearly. But we'll discuss it with you guys online as well. Okay, questions? Else we're going to have a good evening.
Oh, from my side, no question, Jean, and thanks.
Okay, cool. Anybody else?
No,
No
I'm happy.
question.
Thank you.
Okay,
Also good.
awesome.
Thanks, Jean.
Okay, so yes, the recording, I'll download it again later tonight, and I'll